Good day, viewers all over the world. My name is Yemi Opochade. I'm a STEM tutor. I teach, coach, and train people on mathematics, physics, chemistry, further maths, technical drawing, technology-related courses, and so on and so forth. You're welcome to this edition of our chemistry STEM. Which I'll be looking at the part 2 of the 6 classified equations that are meant to be balanced in chemistry. You will recall in the part 1 of this series, we treated how to balance inorganic equation. Balancing inorganic equation. And for a recap on that, we said that instead of the normal norms of trial and error, I've come up with a specific direction to balancing inorganic equation. And the steps are, first of all, balance the hydrogen atoms in that reaction. 2, balance the oxygen atom. Then 3, you now balance any other atoms. If you follow that simple step, you don't need to go into the journey of trial and error. For a recap on that, let's balance this equation. We have calcium phosphate. Reacting with sulfuric acid, H2SO4, sulfuric acid. It will give us an acidic salt, calcium hydrogen phosphate. Then plus calcium sulfate. This is an acidic salt. It is an acidic salt because the hydrogen atom is not completely replaced, so it is an acidic salt. Now, if you look at this, it may look so complex, but if you follow those 3 steps I mentioned, you'll get this balance in less than a minute. This can be balanced in less than a minute. What do? Target balancing hydrogen atom first. At the reactant side, don't forget the law of conservation of energy must be obeyed. Then at the product side, you balance it atomically. You pick each atom one by one. Let's target hydrogen first. At the reactant side, we have 2 hydrogen atoms. At the product side, we have 4. 2 times 2, 4 hydrogen atoms. Can you see it clearly? Yeah. So it means we can balance hydrogen atom by putting 2 here as stoichiometric coefficient. Hydrogen is now 4. Hydrogen is 4. Then the next element you target is oxygen atom. At this side, the reactant side, 2 times 4, we have 4 oxygen. 2 times 4, that's 8 oxygen, plus 2 times 4, another 8 oxygen. That's 8 plus 8. Oxygen atom here give us 16. Now let's see this side. If you look at this side, oxygen is, we have 2 times 4, 8. Plus here we have 4. That is 12. So oxygen is not balanced. We have 16 at the product side. We have 12 at the reactant side, then we have 12 at the product side. So what do we do to balance? If you put 2 before this calcium sulfate, if you put 2 here, then definitely we will have this turn to 8, meaning that this place will turn to 16. So oxygen is balanced. Hydrogen is balanced, oxygen is balanced. Then you now look at the other atom. Let's look at calcium. Calcium here is 3 at the reactant side. At the product side, we have 1 here. Then we have 2 here. You can see 2 calcium. That is 3. Calcium is balanced. Let's look at phosphorus. This is phosphorus, P. How many? This bracket affect this subscript affect this. That's 2. Phosphorus here. How many phosphorus do we have here? Can you see 2? These 2 affect it. That's also 2. Phosphorus is balanced. Sulfur now, it remains sulfur. At the reactant side, we have 2 sulfur atoms. Fine. At the product side, can you see 2 sulfur also? So all the elements are balanced atomically, and it means that number one, this equation is perfect, is correct. Secondly, the law of conservation of mass is obeyed. That is what we did in part 1 of this series. You can search for that particular edition of balancing equation. You get full detail. This is just a recap. Today we are looking at balancing organic equation. How to balance organic equation. Balancing organic equation. It's a different ball game. As a matter of fact, you dare not attempt trial and error in balancing organic equation that involve combustion. That is the area we are looking at, combustion. If you do that, a journey of 2 minutes may take you like 1 hour. I've tried it until I came up with these techniques. It's a very simple technique. In fact, as a matter of fact, balancing organic equation that involve combustion, that is burning, could be more tedious than balancing inorganic equation. But with this method that I have devised, I can tell you that it's even faster because it is a stepwise strategy that you deploy and you get your equation balanced. Now, what we should ask ourselves is that what are organic compounds? We have inorganic and we have organic. Organic compounds are compounds that are associated with carbon elements and hydrogen element majorly. They are associated with carbon and hydrogen. Don't forget that the most naturally abundant element in the world that we find mostly in plants is carbon. Virtually everything we relate with as human being, feeding, pharmaceutically, medicine, drugs, has a component of carbon. And so carbon is an important element to human existence. God make it so. So now, when we say organic compound, I want to zero it down to a particular type of organic compound, hydrocarbons. The hydrocarbons. The hydrocarbons from the name are organic compounds that are made up of carbon and hydrogen only. Other organic compounds can have other elements like the halogens, the sulfur, the nitrogen, and so on and so forth. But for hydrocarbon, they are specifically made up of these 2 elements, carbon and what? Hydrogen. And we classify them majorly into 2. We have the aliphatic hydrocarbon. Let me shorten it that way. And we have the aromatic hydrocarbon. Again, for the purpose of what I want to achieve today, I want to focus on aliphatic. These aliphatic are divided into 3. We have the alkanes, and we have the alkynes. Alkanes. Now, the alkanes are a series of organic compounds that are associated with this formula: CN H2N plus 2. Alkanes are associated with this formula: let me write it properly, CN H2N. While the alkynes are associated with CN H2N minus 2. Now, there could be limitless number of compounds that can be generated under alkanes using this formula, similar to this. Alkanes are similar to this. So, that is that. So I want to go straight to an aspect that relate to this part 2 of balancing organic equation. That is balancing the aliphatic hydrocarbon, that has an even carbon content, even number carbon content, even 2, 4, 6, 7, 8, 9, 10, and so on and so forth. And so we go straight to balancing an organic equation, zeroing down to what I've just mentioned now. So now I want to balance, let's say decaying, and hydrocarbon that is called decaying. When it combusts, when it burns, what's the gas that supports combustion? Everybody knows that it is oxygen. This is how to write oxygen gas. It's diatomic. Then once any hydrocarbon, any of the hydrocarbon, whether it is alkanes or alkynes or any other one, born in oxygen, then the two major products are carbon dioxide, CO2, and water. Now, this decay means that the carbon content, it is this. I can write it like this as Cn H2n plus 2 reacting with oxygen, giving me carbon dioxide, okay, plus water. Now, from the name decay means 10. It means n is 10. So I have C10, then 2 times 10, that's 20, plus 2, 22. So this is decay alkanes. Reacting with oxygen gas, giving us carbon dioxide plus H2O. Now, this equation is incomplete. This equation is against the law of conservation of mass until it is what? Balanced. How do you balance this? It's different from the way we balance in organic equation. To balance the combustion of hydrocarbon or perhaps an organic compound, what you simply do is this. You will double the carbon content of the hydrocarbon. The hydrocarbon in this case is this. Decay. The carbon content is 10. You double it. Don't forget that when you are balancing chemical equation, you can only put number, which is called stoichiometric coefficient, before the compound. You cannot remove anything. You cannot change or modify any of this one. You can only put value to balance. So the first step is that, listen to the first step. Double the carbon content of the hydrocarbon. This is the carbon content, it is 10. To double it, 2. That is 20. 2 times 10. I've doubled the carbon content of the hydrocarbon. Then try to go and look at the other side where carbon is existing. Carbon is existing under carbon dioxide. The carbon content here is 1. You have to balance it. This is 20 here. To balance it here, what do you have? You put 20. You have to put that 20 there to balance it, okay? You have to put 20 to balance it. I hope you are seeing it clearly. Carbon content is balanced. Now, after you balance the carbon content, you now balance hydrogen atom. Here we are at this side, at the reactant side, hydrogen is 2 times 22, that is 44. Hydrogen here is what? 2. What do you multiply by 2 that will give you 44? That is 22. The simple arithmetic is that you just divide this one by 2. Divide this one by 2, it will give you 22. So it means here you have 22. 22. So hydrogen is balanced. Hydrogen atom is balanced. Then you can now go ahead to balance your oxygen atom. So you can see that it's completely different from the way you balance inorganic equation. Now at this side we have 2 atoms of oxygen. At this side we have 40 atoms of oxygen here plus 22. Can you see that? 20 times 2, that's 40. Is that not so? That is oxygen atom. 20 times 2, that's 40. 20 times 1, that's 22. So plus 22. 40 plus 22, what do we have? 60, 62. So we need, but at this side we have just 2. So what do? What do you multiply by 2 that will give you 62? Just, you simply divide this one by 2, okay? That is what? 30. So that means I will put at 1 here. Then the equation is balanced. You can see that. Let's see it. Carbon 20, carbon 20. Hydrogen here 44, hydrogen here 44. Oxygen here 62. Oxygen here 20 times 2, 40. 40 plus 22, that is 62. Now, this goes for any organic compound, whether glucose, sugar, alkynes. Sometimes there may be need for you to reduce the coefficient to its lowest 10, especially when the carbon content is odd. There may be need, but that for today we are not going to that. We have achieved our aim. And you can see that without any trial and error, we got the combustion of hydrocarbon, in this case decay. We get balanced without any trial and error. In knowledge, we keep on improving and making difficult things look simple, making things that look complex simple, and that is what I've just done. So that will come to the end of the part 2 of balancing chemical equation in chemistry. Thank you, God bless, and watch out for my next edition. Bye.